Hello everyone, today in this video we are going to talk about parallax method. So after this video you should be able to use the additional units of distance and derive the formula for parallax method and apply the formula to find the distance. Before we talk about the parallax method, I'll show you a video. So this is a snapshot from a video. So what I want you to do is just you need to observe these three things. Observe an object which is far away, an object which is at some distance, and an object which is very near to the screen. So observe these three things and I'll see you after the video. Okay, welcome back. So you might have observed the object which is very near to the screen moves very fast and it goes backward, and the object which is at some distance also moves backward with less speed, but the object which is far away moves forward with the screen. So now let's understand why this happens. So here I am considering a moon, a lamppost, and someone who is observing the moon. So suppose the distance of the moon is 1 lakh some units and the distance of this lamp is 10 units. So suppose she shift to this position and her distance from the lamppost is suppose 15 meter and her distance from the moon is 1 lakh 5 meter. Now we already know that when we add a small number to a large number, we can neglect the small number. So this is nearly equal to 1 lakh, because adding a small number like 5 to 1 lakh won't affect the value. So I can write this to be 1 lakh. Now if you see, the position of the lamp has changed from 10 to 15. Now I cannot write this to be 10 because 5 is half of the 10, so I cannot write 15 is equal to 10, but out here I can write. Now if you see the position of the lamp, it has changed, but the position of the moon has not changed. So meaning before it was 1 lakh, right now also it's 1 lakh. So the position has not changed, but the position was overhead, so it will come somewhat like this. So position of the moon has not changed, but the position of the lamp has changed. So now let's consider the same case in this side. So out here the position with respect to lamp is 15 and position with respect to the moon is 1 lakh 5. So this can be written as 1 lakh only. So again the position of the lamp has changed, but the position of the moon has not changed, so it will appear just overhead. So if the distance of the object is large, the object moves with you. Wherever you go, it follows. This happens if the distance between the 2 points is small as compared to the distance of the object. So now let's talk about the parallax. Suppose the same girl is standing out here, so behind is some background and we are observing her from out here. So if you look at her from one eye, this eye, she will appear in front of this cyclist, so somewhat like this. And if you look from this eye, she will appear in front of the car. So now if you change the position of the observation point, the position of the object also changes, and this effect is called parallax effect. So parallax is the change in apparent position of an object when it is observed from different position. You can also try the parallax method. Just look at your thumb like this and change the eye, the position of the thumb will change. So meanwhile you can also like the video. With one eye the position of the finger is out here, with other eye the position of the finger will be different. So same thing can be observed with the star. So this is the position of the star when we are looking at it on January. So when we look at the same star after 6 months, that is July, so position will change, but the position of the far away star, you can see small stars, it will not change because the distance is very large and we have discussed it before. So meaning looking at the star during January and July, so during January the position of the earth will be out here, so after 6 months it will reach out here, half of the circular path. So the position of the star changes when we look at it from different position. Now we'll talk about some additional units which we will be using in the parallax method. These are the 7 SI units which we have already discussed before. So now the first unit is 1 micron. 1 micron is 10 to the power minus 6 meter, and 1 millimeter consists of 1000 microns. You can see this is a very small distance, but in this distance there are 1000 microns. So let me give you real life example. Diameter of our hair is 50 to 100 micron, and this is 1 micron as compared to 100 micron. So diameter of paper clip is about 1000 micron, and bacteria is 1 to 3 micron, and pollen grains, which are very small, also has the length of 10 to 20 microns, and the smoke particles has the size of 0.1 to 1 micron. One more real life example, the size of the coronavirus is 0.1 micron, and the particle which can go through your mask is 0.007 micron, so which is less than 0.1 micron. So if you wear the mask, coronavirus cannot enter through the mask. Okay, another unit is angstrom, that is 10 to the power minus 10 meter. So when you write 1 A and 0 at the top of A, then it will be automatically 10 to the power minus 10 meter. And another unit is 1 Fermi, that is 10 to the power minus 15 meter. Another unit we will be using is light year. Light year means the distance covered by the light in 1 year. So we know the formula, speed is equal to distance by time, and distance will be speed into time. So speed of light is 3 into 10 to the power 8 meter per second, and this is 1 year converted into seconds, 365 days, 24 hours, 60 minutes, 60 seconds, and if you multiply this you will get 9.46 into 10 to the power 15 meter. So one light is equal to 9.46 into 10 to the power 15 meter. And another unit we will be using is astronomical unit, AU. So one astronomical unit means distance between earth and the sun. So this is the distance, and when you write in power of 10 you will get 1.5 after rounding off into 10 to the power 11 meter. So I have converted this kilo into meter. So 1 AU is 1.5 into 10 to the power 11 meter. So you need to memorize this units, and this is 1 AU, distance between sun and the earth. The diameter of the orbit of the earth is 2 astronomical unit. From here to here is 1 astronomical unit, and from here to here is another astronomical unit, 2 astronomical unit. We use degree as a unit of angle, but SI unit of angle is radian, not the degree. So out here you can see from here to here is 360 degree, but when you write in radian it will be 2 pi radian. So that means 360 degree is equal to 2 pi radian. So 1 degree will be, so this 360 will go down, and 2 pi by 360 radian. So when you divide this you will get 1.74 into 10 to the power minus 2 radian. And now smaller unit of angle is minute. So if the angle is less than degree, so we measure it in minutes. So 60 minutes make 1 degree. So here we are not talking about time, we are talking about small unit of angle, that is minute. So 1 degree is 60 minute and 60 minute is 1 degree. Now I am converting this 1 minute into radian. So 60 minute is 1 degree and 1 degree we already know 1.74 into 10 to the power minus 2 radian, and 1 minute is equal to this 60 will go down, and when you divide this you will get 2.9 into 10 to the power minus 4 radian is equal to 1 minute. And the further small unit of angle is second. So if the angle is less than a minute, then it is measured in second. So 1 minute is 60 second and 60 second is equal to 1 minute, and 1 minute we already know this is 2.9 into 10 to the power 4 radian. So now 1 minute is equal to this 60 will go down and we have to divide this by 60. So you will get 4.84 into 10 to the power minus 6 radian. So and these are the conversion you need to memorize, and if you don't want to memorize you have to go through this process. Okay, now let's talk about the parallax method. Parallax method is the method to measure the distance of far away object, and in order to derive the formula we will use one formula. So this is a circle with radius r, and if you cut this part only, I will tell this part as arc, this is radius, this is the angle, and the relation between these three is angle is equal to arc by radius. So this is the main formula which we need to derive the parallax method. In order to measure the distance, we consider 2 points on the earth, and the distance between these 2 points is called basis. And suppose this is the moon or any other object whose distance we are calculating, and we have to consider a background, a very far away object whose position will not change when you look from A or B. So the distance of this star is greater than the distance of this object. So when you go to position B, the same star will appear at the overhead, so changing the position will not change the position of the star. So now suppose the distance of this object is r. So now we can measure this angle from the earth. Suppose phi 1 is the angle, and this angle is also phi 1 because they are alternate angle. Similarly, this is the angle phi 2, and out here is also phi 2, and the angle subtended by the object is theta, which is equal to sum of phi 1 and phi 2. So and we consider one arc AB. Instead of distance we will take the arc AB, so that we can use the previous formula we talked about. Now we will derive the formula for parallax method. Now this is the same diagram that I have considered before, and the distance of the object is r from the earth. Now I can consider this portion OABO, the arc, as a portion of circle, and I can write angle is equal to arc AB by radius r. So the distance r is very large as compared to the distance AB. So because this AB is the distance between two position on the earth, and r is the distance of the moon from the earth, so r is much greater than AB. So I can consider this line AB to be arc, it won't affect the distance r. So now we will put the values. So instead of theta I will write phi 1 and phi 2, and AB is the distance or arc, and r is the distance of the moon. So you can find the value of r from here. So r is equal to B. So the distance AB is the basis B, and theta is phi 1 plus phi 2. So now we can measure phi 1, phi 2 and B on the earth. So because we can measure this angle also, and we can measure the distance between AB also. So just by measuring this angle and this length we can calculate the distance of the moon or the object. So This is the general formula. So distance is basis by the angle. So now parsec is another unit of distance. So using this formula, so 1 parsec is that distance if the angle subtended by 1 astronomical unit is 1 second. So you can say if the angle is 1 second and this distance is 1 astronomical unit, then this distance will be the parsec, and 1 parsec is equivalent to 3.26 light year. So when the angle is 1 second and basis, this basis is 1 astronomical unit, then the distance is 1 parsec. So now the distance of the nearest star, that is Alpha Centauri, is 4.29 light year. Now you can convert this into parsec. Try by yourself. And how much is a parsec in terms of meter? So you can use this formula, put the value of 1 astronomical unit, put the value of this in radian, and use the formula angle is equal to arc by radius, and you will get the value of parsec. Now let's solve one question. In this question, moon is being observed from two diametrically opposite point on the earth, from here and here, and the angle subtended by the moon is 1 degree 54 seconds. So you can use the formula of parallax method, but before that you need to convert this into SI unit, that is radian. So now this is 1 degree 54 minutes. So 1 degree is 60 minutes plus 54 minutes, 114 minutes. So you can convert this into radian, and basis is already given, 2.276 into 10 to the power 7 meter. So this is the formula, angle is equal to basis by distance. So next question, the nearest star is 4.2 light year away. How much parallax would this star show when viewed from two locations of the earth 6 months apart in its orbit? So when you see the star after 6 months, the position of the earth will be out here. So the distance, that is the basis, will be 2 astronomical unit, and the distance is already given, 4.29 light year, and you have to calculate the angle. Parallax means angle. So before that you need to convert this into SI unit and this also in SI unit. Next question, the angular diameter of the sun is 1920 seconds, and if the distance of the earth from the sun is 1.5 into 10 to the power 11 meter, then the linear diameter of the sun is, so you have to calculate the diameter of the sun. So angular diameter means the angle subtended by the diameter of the sun, which is given 1920, and the distance is also given, and you have to find the basis this time. Okay, next question. So there are two stars A and B, and the angle of one star is 0.82 second and angle of another star is 0.45 second. So we have to find which star is closer to the earth. So now let's take the formula. So we know this is the distance is basis by the angle. So for earth, basis will be equal, so I'll put the value of angles. So, and when I divide RA by RB to compare the values, so you will get RA by RB is equal to 0.54. So RA is equal to 0.54 RB. So out here you can see 1 RA is equal to half of the, almost half of the RB. So that means RB is greater than RA. So from here we can conclude that smaller the angle, larger the distance. Now let's talk about the limitation of parallax method. So in previous question we have seen more the distance, small the angle. So if the distance of the object is very far away, then the angle will be very small and that angle cannot be measured. So the angle which we can measure on the earth is 0.01 second. So if the angle is less than this, we cannot measure this angle, so we cannot measure the large distance. So using parallax method we can measure up to 100 parsec. I think this is the end of the video, so don't forget to give the parallax method to my video.